So we sub in r is equal to 1. If we want to find the sum of the sequence, that gives us our first term. When r is 1, we get 7 minus 8, which is negative 1. The second term is, we sub in 2. So that's 7 minus 16, which is negative 9. Correct?
Yeah.
When I sub in 3, I get 7 minus 3, that's 24. 7 minus 24 is negative 17. So I can see that my first term is negative 1. And my common difference is negative 8. So if I use the formula, I've got 100 terms. And I've got n over 2. So formula is come on, Cunningham. N over 2, 2u1 minus n minus 1d, 2u1 plus n minus 1d. So it's 100 over 2, 2 multiplied by u1, which is negative 1, plus 100 minus 1, so that's 99, times negative 8. Put that all into your calculator in one go, and you get, what did you say again?
Negative 39,007.
Okay. The way that Greg did it, he used the other formula, your first term, and you got your last term. So he worked out the first term was
negative 1.
Yep, negative 1. He worked out the last term just by putting 100 into this formula. 7 minus 8 times 100. What do you get, Greg, for that?
Negative 793.
Negative 793. And you can work that out, and it will get you the same answer. Okay? Either is absolutely fine. But yeah, don't let this crazy looking notation ruin it on you. Okay, let's have a look at the second one. Oh, no. And so I've got my formula for the nth term. I've got my sum of the first n terms. So I'm going to use the information in the question. We're told the third term is negative 8. So that is u3. So u3 is equal to u1 plus, so I'm subbing 3 into this formula, 3 minus 1 times d, and we're told that the sum of the third term is equal to negative 8. So I've got this formula, u1 plus 2d equals negative 8. Is that okay? And I'm going to use the other bit of information. The sum of the first 10 terms is negative 230. So I'm going to use this formula. So it's 10 terms, 10 over 2, 2u1 plus n minus 1. So 10 minus 1, so that's 9d. And that equals negative 230. So my other formula is 5 times 2u1 plus 9d equals negative 230. So I've got two equations. I've got two unknowns. So what do I have to do with them? Simultaneous equations, right. Anybody want to tell me how to solve these simultaneously?
I would expand the brackets.
Okay. To give you
10u1 plus 45d.
Then what would you do? Somebody else. Ashlyn or Zoe, stop looking at your books. And so what would we do after that if I want to solve these two simultaneously? I've got this equation, and I've got this equation. Greg?
You would subtract one from the other. Or could you add them?
Well, you could only do that if there's the same number of, say, U1s or the same number of Ds. The way I would go about it is to rearrange this one. So I've got U1 equals -8 minus 2D. Okay, so I've just taken the 2D to the other side. Okay? Is that okay, Zoe? And then I'm going to sub this into here. So I've got 10 multiplied by U1, which is -8 minus 2D, plus my 45D is equal to -230. Now, there are other ways to do this. Yes, Greg?
Okay, yeah, I was just going to say I did it a different way. But I was like wondering for the exam, would it be the best to do this?
It doesn't matter as long as you get the right answer, okay?
Okay, yeah.
And then I would expand this out. We'll have a look at your way in a second. So that's -80 minus 20D plus 45D is equal to -230. And then I'm going to add 80 to both sides. I'm going to combine these two terms. I'll do it in 2 steps. -230 plus 80.
-150.
And then -20 plus 45 is 25D. So D is equal to 150, -150 divided by 25, which is -6. You didn't get that, Greg, did you? Did you?
Yes.
You did, okay, good. So D is -6. Now we want the first term. Is that okay so far? I'll stop there for a second, let you catch. All right, so substitute D into this equation. Good stuff. Whack that into the calculator. I get 4 out, so 4 is my first term, and then the sum of the first 13 terms. We're going to use our formula, 13 over 2, 2 times U1, which is 4, plus 13 minus 1, which is 12, times D, which is -6. So that's just subbing it all into this formula. Put this into the calculator. And you get -416. So Zoe's using this one, this equation.
Yeah.
And she realizes this is important, Ashlyn. She knows what's the sum of the first term. What's that equal to? It's actually, but it's equal to the.
U1.
It's equal to the first term. Yeah, the sum of the first term is equal to the first term. So if I sub in 1 into this, so that's 6 times 1. Take away 3 times 1 squared, and 3 times 1 squared is not 9.
Yeah.
So that's 6 take away 3. Sorry, Greg. So my first term is equal to 3. That gives you that straight away. Nice. And then I can work out S2. That's going to be 6 times 2 minus 3 times 2 squared. 2 squared is 4. 12 minus 12 is 0. Right, so my first term is 3. My next term has to be -3 because the sum of the first 2 terms is 0. So that means that my common difference is -6. And then when you've got that, that's asking for the first 4 terms of the sequence. You just can keep going down by -6. What's the next one? Yeah, -9 and then -15. So it doesn't look particularly like a very nice question, but it's actually, as long as you realize this is kind of like your key making it nice and straightforward.